Okay, this is section 6.4, and this lesson is going to be about proving triangles are similar by AA. Kind of looks familiar where we were doing like side angle side and side side side, that type of stuff. That was all about being congruent. This is about being similar. So they will have the same shape, but one will be smaller or bigger than the other one. So the first similarity postulate we're going to use is called AA, and this stands for angle angle. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So all we need is two angles equal, and by our third angle theorem we know that if two are equal then the third one has to be, and once that happens these two shapes are similar by AA. We don't have a side, side, side situation. We're talking here about the angles. So if I can get the angles to be the same, then the shapes are going to be similar. Again, you can have one be bigger or smaller than the other. They're not congruent triangles, just congruent angles. And then I'm kind of enlarging or shrinking the shape, okay? So determine if the two triangles are similar, and if they are, write a similarity statement. So now instead of matching up all the sides like we used to do and write out the proportionality and check and see if all the scale factors were the same, we can use our shortcut of AA. So if I can prove that two of the angles are the same, then the triangles are similar. So right now I got the 90-degree angle, so that's good. This one says 26, and angle C would go with angle K, so that would mean that's 26. And that's 64, that would mean this has to be 64. And then we're just checking to see if that would hold true. Is 64 plus 26 plus 90 equal to 180? As long as all the angles in a triangle add up to 180, then we're good to go. We have equal parts. So this is going to be 90, and another 90 equals 180. So I have, these two triangles are similar by AA similarity. And the similarity statement would be something like triangle EDC is similar to triangle HGK. That's a similarity statement. Okay? So just proving that they are similar by finding me two angles that are the exact same. Again, show the two triangles are similar, so we're looking for two angles that are equal. When I have triangles that are overlapping, like I've said in previous lessons, to make sure that you draw them separately. So I've got this triangle on top, ABE. And then I've got the larger triangle, ACD. And they each have a 52 in this corner, so that's one angle. That's good. And then if you kind of notice, when I separated the two, they still have angle A in common. However much it is, they overlap there. So even when I separate them, they each have angle A. And so I have two angles congruent, so that means that these two triangles are similar. So angle A equals angle A, and then angle B equals angle C. So I've got enough to make it AA. In picture number 2, two things I've trained you to look for are vertical angles or shared sides, and these guys have a vertical angle, so that's one. And then I've got parallel lines here, and I'm going to cut this transversal, and I'm going to use these guys, alternate interior. So I've got AA. I've got angle SRV, this guy right here, is congruent to UTV. That's one. My other angle is right here, angle SVR is congruent to angle UVT. And that means I've got AA. I've got two angles equal, so that means my triangles are similar. Last one says, in a courtyard, a flagpole casts a shadow that is 50 feet long, and a woman who is 5 feet 4 inches casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? So since I know these two triangles are similar, I have one angle there and one angle there. Since the triangles are similar, I can set up some proportions. And I'm just going to match up kind of which side goes with which side. So I know 40 goes with 50. And I'm going small to big, so I have to do the same thing again. It's hard to write 5 feet 4 inches. I can't make that 5.4. So I'm going to convert this all over to inches. So I'm going to do 5 times 12 and get 60, and then add my 4 extra inches. So she is 64 inches tall. I'm going to put that on top. And then X is what I'm looking for, the height of the flagpole. So let me grab my calculator. Doing a little cross multiplying and dividing. 50 times 64, and then divided by 40, gives me a flagpole height of 80 feet. So a little similar to what we've been doing, matching up sides, setting up proportions. Also going to add to the mix today the AA similarity. If you can find two angles that are congruent, then those triangles will be similar.